Hi everyone. In this tutorial we will take a simple example on full wave rectifier circuit using center tapped high voltage transformer. So what is this example? This example is about a load resistance or our insulator which has a resistance 5700 kilo ohm is to be supplied at mean voltage of 200 kilovolt. This mean voltage is also called a DC voltage. The DC voltage of the full wave rectifier circuit should be 200 kilovolt. This DC high voltage is obtained using full wave rectifier circuit with center tapped high voltage transformer. This high voltage center tapped transformer has a voltage ratio 220 over 300 kilo volt. Also, the supply frequency is 50 Hz. What is required? Find the suitable value of smoothing capacitor to be used with this rectifier circuit. This requirement is to find the value of smoothing capacitor. How we can do that? First, let's get the givens of this problem. First of all, we know that the resistance of the test object is 5700 kilo ohm. Also, the supply frequency is 50 Hz, and the DC out voltage is 200 kilovolt. This can be obtained from this information. Now, this is an important given. What is the maximum value of this circuit? The maximum value of full wave rectifier center tapped high voltage transformer is half of the secondary of the high voltage transformer, because here high voltage transformer is center tapped at the midpoint of the secondary. So when the midpoint of the secondary circuit of the high voltage transformer is earthed, we will get two voltages in the secondary of the high voltage transformer. Each voltage is half of the total voltage of the secondary of the transformer, and this of course is explained in the previous lecture. So the maximum voltage here is half of the secondary of the high voltage transformer. So the maximum voltage will be half of 300 kilovolt, but don't forget to multiply by root 2 to obtain the maximum voltage, as this value, which is 300 kilovolt, is an RMS value, root mean square value. To obtain the maximum value, we multiply the RMS value times root 2. So finally, the maximum voltage of this circuit is 212.13 kilovolt, and this is the maximum voltage of our full wave rectifier center tapped high voltage transformer. So this is the givens of the problem. Now we want to obtain the value of the capacitor. We can make use of the simplified waveform of full wave rectifier circuit to obtain the ripple voltage. From this waveform, we know that the DC voltage, which is here, equals the maximum voltage negative the ripple voltage. If we subtract the ripple voltage from the maximum voltage, we will obtain the DC out voltage from this simplified waveform. By substituting with the maximum voltage and the DC voltage, we will obtain the ripple voltage. So DC voltage is 200 kilovolt, and the maximum voltage is obtained, which is 212.13 kilovolt. From this equation, we can obtain the ripple voltage, which is 12.13 kilovolt. You should know that why we obtain the ripple voltage, because to find the value and design the value of the smoothing capacitor, we should obtain the ripple voltage, because the value of the smoothing capacitor controls the ripple voltage. If the smoothing capacitor increases, the ripple voltage decreases, and vice versa. So if it's required to obtain and design the value of the capacitor, we should first know what is the ripple voltage and what is the restricted ripple voltage. Here, the ripple voltage should be limited to 12.13 kilovolt. So from this equation we can obtain the value of the capacitor. This equation says that delta V equals maximum voltage over 4 FR L times C. As we see, the ripple voltage here in full wave rectifier circuit is reduced in case of full wave rectifier circuit compared to half wave rectifier circuit is reduced to the half. So by substituting with maximum value of voltage and the frequency and the resistance and also the ripple voltage here, we can obtain the value of the capacitor. The ripple voltage is 12.13 kilovolt. Maximum voltage is 212.13 times 1000 volt, and we have the supply frequency is 50 and RL is 5700 ohm, and also we have the value of the capacitor to be determined. So the value of the capacitor finally will be 15.34 nanofarad. This value shouldn't be less than 15.34 nanofarad because the capacitor, if the capacitor decreases, the ripple voltage will increase, and we don't want that to happen. So the value of the capacitor will be 15.34 nanofarad to restrict the ripple voltage to 12.13 kilovolt. So this is an example of full wave rectifier with center tapped high voltage transformer to design the value of the capacitor to restrict and limit the ripple voltage.